Delight yourself in how borrow is rooted in commonplace need and practice. Borrow is a simple example of how rooted mathematics is in the real world. Education unreasonably uses abstracted mathematics. The first reel presented the 6-step subtraction process in 3002-3. But what is that about subtraction which seeds the complex process? We will uncover it in this reel, and you would be surprised at the finding. After discovering the need for borrow, we will explore the process of subtraction process without the need to borrow. However, even the simplest subtraction without borrow has its logic. We would demonstrate the need and nature of borrow of quantities with simple everyday situations. Children routinely borrow or share toys, pencils, food, etc. Here is a sales situation where a small store has 17 eggs to sell. As usual, eggs are stored in packets of dozen. Thus, 17 eggs are kept as one box of 1 dozen eggs and 5 loose eggs. It is as if there are 2 packets of eggs, packets made of dozen eggs each, and packets of single eggs only. In such a situation, a request to buy 6 eggs can only be fulfilled by giving away the 5 loose eggs and borrowing 1 egg from the box of the dozen eggs. The packets of dozen eggs and single eggs are separate. It is important to realize that the borrowed egg is not out of the store. It is borrowed from another kind of packet. 6 eggs will be sold as loose eggs, being less than the packet size of dozen eggs. Any shortage in the loose eggs will be taken from the dozen eggs packet. Borrow from a packet leads to its dissolution. It becomes another kind of packet. Here, the dozen packet is now loose eggs packet with 11 eggs. There is no packet of 1 dozen eggs anymore, only 11 loose eggs. We rigorously practice segregating and transacting things in packets of different sizes, and we maintain the integrity of packet contents. For example, a dozen packet must always have dozen things. We have lost a packet of dozen once 1 egg was borrowed from it. There is 1 less of dozen eggs packet. In another situation involving purchase demand of 4 eggs, no borrowing is needed. 4 eggs are loose eggs, being less than the dozen packet. There are already more loose eggs than required to be sold. When the quantity in a packet is enough to be subtracted, there is no borrow. The same is true for money to be paid. If we have the exact denominations to be paid, we would not pay using a higher denomination note, that is, not borrow from another packet. We could easily pay 22 rupees from the money we had. There was no need to borrow from the 100 rupees packet. The need to borrow is applicable to numbers also, because numbers are not a heap of one size of packets of quantity. Borrowing of quantities is between packets. If there were only one kind of packets of numbers, there would be no need for borrow. But numbers in decimal number system are bundles of different kinds of packets. 21 minus 6 can proceed only when 110 packet is borrowed from 21 and decomposed into 10 units. The need for borrowing comes about due to the fact of different packets in a numbers. This is a very significant logical and conceptual understanding of numbers themselves. We are now ready to witness the steps in the process of subtraction where no borrowing is required. We will observe a no-borrow subtraction expression, 3003 minus 2. Visualizing 3003 minus 2 using number blocks. Let us carefully observe the subtraction process. We also visualize 3003 minus 2000. Despite being no borrow expression, it expands the understanding. 3003 has no 100s and 10s, and 2000 has no 100s, they're 10s and 1s. Observe the animation carefully. Borrow is to complete the quantity to be subtracted. By default, it also breaks the packet that is borrowed from. Thank you. With us, you will master all the mathematics you need. Be good to you, not just others.